So hi there. Thanks for coming. My name is Chris, and I'm going to be talking a bit about continuous delivery for Android apps and how implementing this with Jenkins might be simpler than you might think. So quickly, a bit about myself. If the clicker works. There we go. There we don't go. Whoa, okay, interesting. I live in Cologne in Germany, a very nice city. I work there as an Android developer. I'm a freelance Android developer. I've been an Android developer, a mobile developer, I should say, for about 10 years now. And most of that time has been in Android. Although I live in Germany, as you can probably hear, I'm not German. I'm actually Scottish. And I spend a lot of time as a Jenkins user. I've been using Jenkins for a long time. I've worked on some Jenkins plugins for Android, for various things. And I spend a bunch of time on Stack Overflow now and then, answering Android questions and Jenkins questions and that kind of stuff. OK, so what kind of problems do we have when developing software in general? So normally, there you are as a software developer. You're pretty happy. Things are going well, but then there's deadlines, there's pressure to deliver. People are always wanting updates, so your QA person comes along and says, hey, I want the latest build of the app. And then you've got your manager coming along saying, hey, I want to be able to test all of the changes that are coming up. Then you have your client coming along saying, hey, I want a new build all the time. I want to be testing all these great new features you're developing. And then you've got your users as well, and your users are saying, hey, where's the new stuff you've been promising us? We want to try out the cool new stuff. So all of these people want a new version of your app basically as soon as possible, preferably yesterday. So what can we do to take the pressure off us as software developers and try and make these people happy? So in continuous delivery, of course, something very important is to automate everything, automate as much as possible. Software developers like to be lazy as well, so the more things we can automate, the better. The fewer things can go wrong. So we want to do stuff like automating the build of our apps, making sure we're building in a clean environment, and not just having this works on my machine problem. We want to help with quality assurance, make sure that we're delivering apps that have decent quality, that are going to run on as many devices as possible. And then delivery. So if we've passed these first two steps, we want to ideally automate the delivery direct to the users without having to do anything. So what benefits does this bring us? So it's the usual kind of continuous delivery stuff. So the more you automate, the less chance there is for human error, the less chance there is for things going wrong. So when you're building Android apps, you don't want to be manually building your apps yourself and then making sure you're using the right signing key and then making sure you're uploading it to the correct server with the correct permissions and all of this kind of stuff. You can deliver fixes faster. If you can automate your delivery pipeline for apps, you can deliver fixes to your QA testers or your client or perhaps beta testers. So these are kind of the benefits we get from continuous delivery in general. So what specifically are we going to look at here in this talk for Android apps? So the goal I'm going to try and get to is being able to do a git commit, checking your code, tag your repository, and then push that. And then after that's done, your users will have your app. So there's nothing else. It's basically all automated from this point on. So this is what I would like to do, be able to git push to Google Play. So this can be done, as we'll see, but there are a couple of kind of caveats along the way. So if you're building a web app, you can deploy all the time, and your users get your app straight away. All they have to do is refresh the web page, and they've got your latest deploy. But for mobile apps, these are distributed via an app store. And so users, you don't want to have users getting an update notification on their phone every 5 minutes or every couple of hours because you've pushed an update. And you see people in Google Play complaining about this. If you update too often, even though that seems like a good thing, people start complaining, oh, hey, you're using up my data. I'm getting notifications all the time. And you see people commenting on this on Google Play. So while you can update all the time, it's possibly not a great idea to end users, but you could do this internally inside your company or to alpha testers or to beta testers. And Google Play has this feature where in the Play Store, if you've opted into beta testing, you get this extra tab So for some users, it's OK. They won't be annoyed as much by constant updates, but it's something to kind of think about. So how are we going to achieve this? Well, as we're at Jenkins World, of course, we're going to be talking about Jenkins, but what exactly are we going to be doing? So the first part of the process is, is to build your app, to make sure you're building your app in an independent environment. But before we do this, we need to do some preparation. So if we're going to be delivering our app regularly to testers or to users, we want to be able to determine from any given APK file, from any Android app, which commit this corresponds to. So if you have 3 different versions of the app, say you've built the app, given it to a tester, and they come back later and say, I found a bug. And you say, OK, which version of the app do you have? And they say, I don't know. That's not particularly helpful. So what we want to do is we want to be able to go from a particular APK to exactly to a Git commit. We want to build traceability into our apps. So one of the problems with making releases on Android is that you always need to increment these, this version code field here. So this is the Gradle build file for our standard Android app. You have this version name, which is basically user visible, and you have a version code. And this is the thing you need to be you need to remember to update, to increment this value before you make a build and give it to someone. Otherwise, you can't really figure out where the app's coming from. So one thing that you can do is you can generate this version code programmatically. So instead of saying version name is a static value, 1.4, version code is just 4, what you can actually do, because Gradle scripts are essentially Groovy scripts, you can write a function that calculates this dynamically. So what I've done here, and what I do for a bunch of apps, is along the top here, you can see we're defining some version numbers. So we've got this version 1.4.0, essentially. And what happens then, instead of static values, we're calling a method here. And for the name, that will just concatenate those together. So we end up with 1.4.0 as our version name. And here at the bottom, we then calculate, we have to calculate this version code. And that will end up being, for example, for 1.4, we also take the Jenkins build number. So for every Jenkins build, you have this build number environment variable, and that's always increasing. So what we do is at the bottom here, we add this into the version code. So that means our version code is automatically incrementing for every single build we do. We don't have to manually increment this and then commit it and then do a build. It just happens automatically. So that's pretty nice. So some of this stuff is a bit more kind of convenience, but this, again, for traceability, this version name suffix here is quite handy. So you can say, when someone installs the app, instead of just seeing 1.4.0, they'll see 1.4.0 build 17, for example. So this came from Jenkins build 17. And then you can go back to Jenkins and see, OK, build 17 corresponds to this Git commit. So so that's how you build kind of traceability in there. Another nice thing for Jenkins is, for Android, is every time you build an app in debug mode, you have to sign it with a key store. So here, this debug key store is generated automatically on every Android machine, every build machine. It's generated the first time you build something. So that means every build machine has its own debug key store, which is unique. And the problem with that is, if you build your app on one machine one day and install it on your phone, and then build it on another machine another day and try and install that, you'll get a conflict because the signing keys don't match. So one way around that is to check your own debug key store directly into your repository, and then in your Gradle file, instead of allowing Android to just use the default from the local machine, it'll use this debug key store from the repository. And that means you always have a consistent signing key for all of your apps, regardless on which Jenkins machine it was built. OK. So again, building Android apps, there's a few prerequisites that we require. Of course, the source code kind of is pretty helpful for building your app. You need the Java tools. You need the Java JDK. And of course, you need Gradle. So with Jenkins, this is pretty easy. So this can be automated pretty well. So of course, we have the Git plugin or any SCM plugin that you're using. the JDK can be installed automatically by Jenkins if it's not already installed. And Gradle can be installed automatically as well. So Android apps normally use the Gradle wrapper. There's also a Jenkins plugin that can install Gradle for you. So there's very little manual setup that you require on your Jenkins build machines in order to get going. So that's the basics. So on top of that, we need the Android prerequisites. You need the SDK, Android SDK. You need the Android SDK build tools. You need the platform that you're compiling against for Android. And you also need stuff like dependencies, the Android support libraries that people are always using. Again, these can be automatically installed. So the Android Gradle plugin, in its very latest version, 2.2, which is actually, it should be coming out anytime around now, that actually now has the functionality built in to automatically install an Android SDK for you, to automatically install the build tool you require and the platform and the support libraries. There's also some other ways of doing this. For example, there's a third-party Gradle plugin called Android SDK Manager, but that's kind of not so well maintained nowadays, so it's probably better to go for this new official Android Gradle plugin. And one thing I've been seeing people talking about recently is using, for example, a Docker container. So pre-building a Docker container with all of the SDK stuff built in. That seems like a decent solution, but unfortunately, you probably won't find any Docker containers on the public Docker Hub with all of the Android stuff, because the Android SDK licensing is kind of a bit weird. So you're not allowed to redistribute the SDK components, even though they're all open source. I don't know why Google decided to do this. Anyway, so there's a bunch of possibilities of making sure your build machine is ready for Android. So yeah, just as I mentioned, the Android Gradle plugin, all you have to do to enable that is add 2.2 to your build Gradle file. And then the thing that's not enabled by default is this SDK download. You need to set SDK download to true, and then in Gradle, things will start installing automatically. Okay. So I'm going to explain this with pipeline syntax, but you can do the same thing with freestyle. So what I'm going to do here, the nice thing about pipeline is that you can define your own methods. So for example, here, I'm going to use this Gradle plugin, and I'm defining my own function called with Android SDK. And that takes a block of code that you can run inside of this function. So as I mentioned, this kind of weird licensing situation for the Android SDK requires that you write the hash of the license text to a file in your SDK directory. I don't know. So that's what we do. We just have this write file step, and we write this hash in there. And then we have a with env, so that's exporting an environment variable. We're telling the Jenkins build, okay, my Android home, that's my SDK directory, is here. And then I run this body, I run this block that I pass into it. So we'll see that on the next slide. So building an app is relatively simple here. So I'm just using, I'm using a sample app from Google. I'm just using the Git plugin with the Git keyword to check that out. And here I'm using my function that I defined, this with Android SDK. So that makes sure that everything I run inside of that block will automatically have an Android SDK installed and up and running and install the dependencies for me. So I'm just using the regular Android build system. I'm just using Gradle, and I'm saying, please build my app in debug mode. And then at the end, important for any Jenkins build, make sure you archive your artifacts. So I'm just saying archive the APK file that was built. That means that someone can come along later to Jenkins. If they want to manually download that APK, they can do that. OK, let's try and prove that this works. Whoa, sorry. So I'm going to switch over to my browser. And I'm going to make this a bit bigger, that it's readable. So here I have a job called build, which builds, as you might guess. So going down to the configuration, it is essentially the pipeline I just mentioned, if I can make that a bit bigger as well. We're checking out the code. We have this with Android SDK block. And what I've done here is we've got the assemble debug, but I've also added lint debug. So lint is a really nice Android tool in the SDK that helps you find any potential problems with your code, whether it's you've forgotten to localize some strings, or you've introduced some security vulnerability, or there's lots and lots and lots of checks. So it's a really nice tool. So you can just run that. That produces some XML output. And what we can do here with the Android lint plugin is just say Android lint. And that will analyze the results and produce a nice report for you. Then we're archiving the APK. And there's this Android stuff I was talking about before. So if I go and hit build now, it should build now. If I make that, oh, I need to make that a bit smaller. So here the build is running. It is checked out the code. It is running inside of the Android SDK block, so it's making sure there's an SDK installed. It's installing any prerequisites. In this case, they happen to already be there. We scroll down to the bottom. It's compiling. It's running the lint checks. And already it's successful. And at some point we see, collecting Android lint files. It's already doing the analysis. So if I click up on the build page itself, we'll see that the debug APK file has been archived already. There it is. I can just download that. And we've got this lint issues. So I can click through to that to see a report. I've got 15 issues. There's a lot of red there, which is not a good sign. But we can click through into details and see, OK, so what's wrong? For example, I've used a deprecated XML attributes. So I shouldn't be using single line anymore for an Android UI, for a text field. I can click through and then see that in context. So I see this line highlighted. Oh, this is a problem. I can hover over it, and I get the error message. And what I also added into the pipeline was I said, if there are any severe errors, mark my build as unstable. So you see here that this build has been marked as yellow as unstable. So that can encourage your developers to be very kind of ruthless about fixing lint issues as soon as they happen. You can mark your build as unstable if there's severe errors introduced. OK, so switching back, that was that. So another fundamental part of continuous delivery is testing. So if you want to push code out to your users faster, you have to have confidence that it's working. So of course, this requires writing tests. That's an entire talk in itself for Android. I'm not going to get into that. But for Android, it has a lot of good testing frameworks. There's JUnit 4 built in. There's also the Espresso framework for writing UI tests. And the good thing about these is the output the results in JUnit XML format. And this is something that's built into Jenkins, or with a JUnit plugin is available. So as long as you can output your results, regardless of which test tool you use, as long as you can output in JUnit XML format, then Jenkins can read these in, parse them, show some nice graphs, mark your build as unstable, send out email notifications, whatever. Yeah. So once again, we need a job. This is very similar to the previous one. The only difference here is a couple of things. So here, along with just building the APK, we're also running the unit test. So we're just saying test debug unit test. That's the name of the target. And once again, with pipeline, it's very simple. We just say JUnit, and then we put in the pattern of the XML files. So all of the XML results always start, whoops, sorry, always start with test. So that will just analyze those and show the results. So that's unit tests. But if I go to Google Play and upload an APK, I see this page. And this tells me exactly for the APK I've uploaded with the constraints it has. So I upload an app that says, oh, I only work on Android 4.4. I require a camera and a GPS. Then I see this here, supported devices. It tells me how many devices support my app. And in this case, this is 3,572, which is 3,500 separate device models, each with a different Android OS version, each with a different amount of RAM, each with different hardware capabilities, with different screen sizes, and all of this kind of stuff. So this is the thing that makes Android nice as consumers, this diversity, that there's so many devices out there to choose from, whether it's phones or tablets or everything. Android's kind of on a lot of devices. So this is nice, but it's a bit of a pain for making sure that your app works as well as possible across so many of these thousands of devices. So what can we try and do here? So we all have all of these Android, we have these different Android versions. We can't buy 3,000 different phones to test on. But one potential solution is to use emulators. There's also, you can use test clouds. You can use, from Google, they have a Firebase test lab you can upload and test on some real devices. But one thing you can do with Jenkins is start up Android emulators to test common device configurations. So if your app works on Android 4.4 up to Android 7, you could start up a bunch of emulators with these versions. If you support English and German and French, you could then also start emulators with these. And basically cover the fundamental configurations, configuration variants that your app should have to deal with. So matrix jobs, or multi-configuration jobs, as they might be known, is a really powerful feature of Jenkins. So this allows you to run the basic same job configuration, but with a few variables. So I can say, I want to start an Android emulator, but I have some variables. And in this diagram here is an example. It's testing a bit, quite a few different combinations. Maybe you don't need so many. Maybe you just want to concentrate on the OS version and languages. But here you can say, I want to run an emulator for all of these different combinations. So I want British English on XHDPI on Android 4.2, for example. And each of these dots represents a build, and that represents an emulator being started up, your tests being run, and the emulator being shut down again. So I can try and demonstrate that as well now, using the Android emulator plugin. If I switch back. So, if I find my mouse, there it is. I have a basic matrix test here. Oop. So you can see I've defined 2 axes. I've said, I'm not sure why I chose only 5.0 and 5.1. Normally you choose, what I like to choose is the minimum Android version you support, so maybe that's 5 or 4.4, and a more recent version. And then on top of that, so the apps that I work on tend to be for the European market, and we have a lot of languages, whether it's English, German, Dutch, and French, and all of this stuff. So I like to test on different languages as well. So in this case, I've defined a matrix job. I'm just going to, it's a bit hard when the screen's so huge. So I'm just going to start this building, and we can take a quick look at the configuration. So, so here for a matrix build, I've checked out the code. So here you have your matrix axes. So I've defined, as we saw on the screen just there, I've defined one called operating system, that's 5.0.5.1. I've defined another axis called locale, and there's my 2 languages. And so here, so unfortunately the Android emulator plugin doesn't currently support pipelines, so this is more of a kind of freestyle style of job. But here we say, during the build, I want to run an Android emulator. And here we have the ability to configure exactly what we want. So here I've just said I only want 1 screen size. But here we can use these variables that we defined. So in the matrix job, your axes are exported as environment variables. And here, OS and locale will be exported. And then further down, I'm just saying, run my, so the thing at the top here, because I'm using an espresso test, espresso requires that you disable animations during the test, and that's just some ADB commands that will do that for you. And then I'm just running the regular Gradle build for running a UI test. And then at the bottom, as we did before, we're going to parse the JUnit XML. So if I go back, we will see, so these are currently flashing, and my laptop's getting hot because it's currently running 2 emulators in parallel at the moment for Android 5 and 5 for English and for German. If we click through there, we'll see that it's checked out the repository, starting Android emulator, and it's one that's got the exact configuration that we asked for with Android 5.0, English, British, waiting for the emulator to start up, somewhere around here. Emulator is ready for use, and then our build starts. So the whole Gradle stuff, Gradle, 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 building, 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 lots and lots of output. Skip to the bottom. So now you can actually see the tests running on the device. So these will all run through. We'll get the JUnit XML output as before, and well, this is going to take a couple of minutes. I think it only takes about 5 minutes in total to run all 4 combinations. Of course, if you had more build machines, this would go even faster. But if I click through, for example, if I visit the previous build, I can see everything was blue, test result, no failures. I can click through and see, yeah, so they all took around 2 minutes to run the tests. All 58 tests passed, and yeah, so then if you have failures, you can see exactly in which combination it happened. Perhaps you introduced a failure that only happens on Android 5.0, for example, then you'll see that these ones go yellow or red, and these ones remain blue. So yeah, that works pretty well. So that was unit testing as well. Oh, I can quickly go back and show that, actually. In our previous job, we did have unit testing built in build. And there's the unit test results. So this app has unit tests, which run very fast. So these took 29 milliseconds to run. So you can run them very easily. But for the UI test, you really need to start up an emulator, and that's going into multiple minutes rather than milliseconds. So that works. So with the app built, we've somewhat proven that it works, that it's got decent quality. We don't have too many lint issues. Where all of our UI tests are passing, all of our unit tests are passing. So we're ready to deliver. So there are various ways that we can get an APK from Jenkins to users. So there's a really basic one, just upload it to a web server somewhere and get your users to download that. That's kind of, from a user experience point of view, that's pretty awful. Users have to download from a web server, find it on their device, let it install, and you have to go into the settings and say, yes, I want to allow. It's not a good idea. There are third-party solutions. So Hockey App is one that I've got a lot of experience with for uploading builds to customers or internally for distribution throughout the company. Crashlytics is another one. There are plugins, Jenkins plugins for both of these, so you can just say at the end of the build, I've built my app, just upload it now, and that will do the job of notifying your customers, oh, hey, there's a new version, go and test it out. The third option is Google Play itself. So Google Play, since a couple of years now, has got an API that allows you to upload directly to the Google Play Store, whether it's an alpha test, a beta test, or straight to production. You can also do a staged rollout and say, I want to upload my APK, but only to 5% of users, and then you can increase that. You can ramp up to 100%. So we're going to look at the Google Play Publisher plugin here. So there's a couple of different approaches you can use. So you can build your APK down here at the bottom, and then say, OK, I'm going to upload that to my alpha testers. And maybe this version that you've built here has more extra logging, extra analytics, extra crash reporting built into it. So when you don't want to give this to customers. When you do want to go live, you build another APK, and you can have a separate Jenkins job that uploads that to live. The alternative approaches, which is also supported by the Jenkins plugin, is you can upload this APK. You've built this APK in release mode. You upload it. And then there's a build step that allows you to promote an APK. So you can say, this APK in alpha, I want that to be in beta now. And that will go to your beta testers. And once you're happy that there's no problems there, you can say, you can have another Jenkins job and promote that to live. So the same APK, you've just uploaded it once and just pushed it through the pipeline to the end. So once again, there's some kind of preparation we need to do before we can upload to Google Play. So one thing I like to do, so this is the normal build Gradle for your signing configuration. You need to sign your builds with a release key, and that needs to have, you generate a key pair, and that's stored in a Java key store file. So I normally store that key store in my repository, but because you also have to have a password on your key store, I don't like to check that in because I don't want to have both of these secrets in the same place. That's not a good idea. I want to keep the password as secret as possible. I don't give it out to developers. I make sure that all of my releases are done from Jenkins. So the way I do that is I use the credentials plugin to store the key store password inside of Jenkins. So then it's secure, it's encrypted on disk, and I don't have to give out the password to any of the developers. And what I do at build time is inject that password into the environment. So here, once again, it's groovy. So you can do things like system.env.release password. So those will be injected. This will only work if it's being built on Jenkins. So this is a pattern that I use often. To actually deploy as easily as possible, I want to deploy, like we said at the start, when doing a git tag. So what I do is I tag the Git repository when I'm ready to do an alpha or a beta build. I tag it with alpha / whatever, alpha timestamp or whatever, some unique identifier. Git allows you to attach a message, much like a commit message. When you create a tag, you can attach a message. So I use that quite often for adding release notes. I don't want to just send a list of commit messages as the changelog. I type in my own one here, a brief summary. So then I have a Jenkins job, which is triggered by a webhook. So normally, I have Jenkins jobs that are triggered whenever there's a new pull request or when I push to master or to develop. But in this case, I have another Jenkins job that's only triggered when it sees a new alpha tag. And when this build runs, it uses the git tag message plugin to export that tag message into the environment so it's available. I have the release notes. As we said, we inject the signing key store password. Of course, you build the app and let it be signed by the build system. And then we upload the APK to Google Play. And the APK, the Google Play plugin allows us to specify release notes for an APK for different languages as well. So here I've gone essentially from a git tag to Google Play. And this is what it looks like in pipeline. So here, because I'm doing a slightly more complex git checkout, I can't just use the git keyword in pipeline. I'm using checkout. So I'm specifying this ref spec, which looks a bit cryptic, but it's basically saying I'm only interested in tags, specifically tags that start with alpha, and then a slash, and then this star, kind of a wildcard. And then I'm using the credentials binding plugin, like I mentioned, to store my key store password. So I've already created a credential earlier in Jenkins called my app signing key password, and that will be exported as an environment variable. And then I'm using the with credentials step at the bottom to make sure this password is only available during this small phase of the build. Again, I'm using my SDK step, and yeah, I'm building the release. So continued, I now have my APK. It's been built. It's been signed with the release password. And now I'm ready to upload to Google Play. So it's a single step. We have this Android APK upload. Once again, for Google Play, I've linked my Google Play account with Jenkins. So once again, I have a credential that's called Google Play in this case. I'm telling it to upload all of the APKs it finds in the workspace. So normally, this is going to be just one APK. But for larger apps, you might have used this multiple APK feature of Android. I'm saying I want to upload it to alpha users only. And then optionally, you can specify the recent changes text. So here I'm just saying English, oh, hey, this came from build number whatever. In German, hallo. Yeah. OK, so let's demonstrate this. Let's try and see if I can do a git push and have an app end up on Google Play. Yeah. So live demo. Who thought of this? So here I am on my terminal. I am in my Git repository. I don't have any changes. I'm just going to, what am I doing? Build Gradle. So here we see this. I've got, at the top you see version major minor. So my last release was version 1.3. So I'm going to replace this, no. I'm going to say this is now version 1.4.0. We see that's in Git. I'm going to do Git commit Update to 1.4. And then I'm going to say git tag message. Wow, this is amazing. Alpha 123. So then I would do git push. So this repository is just locally on my computer at the moment. It's not on GitHub or anything. So I'm not going to do a push. But I've done everything I need. So I can switch back to Jenkins. So normally at this point, you know, a webhook would come through and it would say, hey, there's a new alpha tag. Please do something. But in this case, I've got a release build job. So I'm just going to push that manually. We'll see that it started running. And that's basically got the pipeline syntax that we just saw. So there's nothing really to see in the config. It says, oh, hey, I found alpha 123 tag. I'm going to make sure there's an Android SDK available. I'm going to build. Build was successful. It was signed. And then here we go. So uploading to Google Play. Spinner. Interesting. Hey, success. Hooray. So what we see here is this version code was generated automatically. So this is, at the top, you can see this is build 18. And I created 1.4, so we see that it's 140018. So I can go directly, when I have an APK with that version code, I can tie it directly back to this job. So that was uploaded to Google Play. I can even switch over to Google Play, which is a bit small. Here at the bottom, you see I have some old version, 132. If I refresh the page, we should see 14018. There it is. So it worked. If I click on the details, I can scroll down and see there's my release notes. Oh yeah, so in this case, I didn't use the release notes from the git tag, but just hard-coded like we saw in the slides from build 18. And in German, vom Build 18. Yeah, so that's it. It actually just did a git push to Google Play. It's pretty cool. So, thank you. Yeah, so we've demonstrated how easy it can be. We can continuously build and deliver Android apps. Building, we've made sure that commits are built in a clean environment. They're not just built on a developer's machine. APKs are archived. They're available to download directly from Jenkins if you want to. We've done various tests. We've done some kind of static analysis. We've done lint. We've done unit testing. We've done device testing, or rather emulator testing, on 4 different configurations. And we verified that everything works. And then delivery. So releases can be made simply by tagging your repository and doing git push. It works. And once again, the signing is secure. You don't have to have developers with your key stores, with your passwords running around. It works. So finally, everyone's happy by we've improved the delivery process. And again, we're back to being happy. So that's it. Thanks very much. Why do I use shell scripts for Gradle in my pipeline? Because it's simple. I guess there is also a Gradle step. Actually, normally, for all the jobs that I haven't yet converted to pipeline, I do use the Gradle plugin. So I guess I could have used that there, but I guess it's also like a one-liner. There's not really much difference. Both work, but yeah. Right, so the question is, with the emulator plugin, how does it launch an emulator? And how do I then install the app onto it? So the emulator plugin basically automates as much of this for you as possible. So if you say, I want an emulator that has Android 5.0 in British English and a certain screen size, if that emulator doesn't already exist on the build machine, the plugin will create it for you. If Android 5.0, the system image isn't on the machine, it will download that for you as well automatically. It will create the emulator using the Android AVD command line tool. It will then start up that emulator and wait for it to be started. Once it is started, then the rest of your build steps just execute. So at this point, there's a freestyle build step for installing APKs. There's a freestyle build step for uninstalling APKs. But in this case, I just use the Gradle build system. So if you run Gradle connected device Android check, that's just one of the Gradle build targets, that will automatically install the APKs onto an emulator or any device it finds on your build machine. And it will run the tests and create this JUnit XML output. So all I did in my pipeline there, my job config was I ran Gradle. I checked the checkbox for the emulator, ran Gradle, and that was it. That's all I had to do. It just uses the standard Android test runner to run the tests. So the one that you specified in your build Gradle, if you did specify one, it's just the default Android test system. There's nothing kind of special there. Right. So the question is whether I used whether I used pipeline jobs or whether I used matrix jobs. So actually, I used a combination because, as I mentioned briefly, if I go back to the sorry, that's too small. If I go back to the home page, we had a couple of So this matrix one, this test job, that's the one that ran the 4 emulators, and that was a matrix job, which is essentially like a fancy freestyle job. I did that because this matrix functionality, that's exactly what I want. I want to have these 4 different emulators. That could be done with pipeline, with like parallel steps, but the Android emulator plugin itself doesn't yet support pipeline. So I couldn't do that in a pipeline, but all of these other things were pipeline. It's exactly the same code that I showed on the slides. It was running in a node, running Git, running this with Android SDK. It was all pipeline, except for the UI tests. Yep. No? Well, I'll be around for the rest of the conference. I'll be giving a demo of some of this stuff later at the open source hub in the exhibit hall, in case you really want to see this again. But I'll be around there for questions, and yeah, thanks a lot for coming.